Okay, so title of our notes, we're still in 9.1, still talking about regular polygons. Well, we're on part 2 though, okay, of this topic. And so we're going to jump right into an example. Find the area of a regular 30-sided figure, 30-sided polygon. Forgot my G. That has a radius of 4. Okay, so on this one, we're going to definitely approximate our answer to the hundredths place. So if you have your calculator with you today, you can use it. And this whole unit, you're welcome to use a calculator. A lot of the problems will not be calculator problems, but some of them will. And then on the test, when we take the test, the calculator is also welcome. And part of this learning is when do I use that calculator, when do I not need it. And so if you see the word approximate, that's going to hint. We're gonna pull out that calculator and use that. If you don't have a calculator today, don't worry. We can do most of this work without a calculator. Okay. So I'm not going to try to draw this 30-sided polygon. Okay, we're going to just draw a piece of it. But the method that we've used with the hexagon, we can apply to what we've used with the 30-sided polygon. So I'm going to draw just a few of the sides, right? And this thing just keeps going around this somehow. Here's our center, and we're given that the radius, so the radius is from the center to a vertex, has a length of 4. Let's say it's 4 feet. And I want to find the area of this 30-sided polygon. Well, our method is going to be to find the area of a triangle. And in particular, this triangle right here, which is an isosceles triangle, both side lengths of 4. If I could find the area of that triangle, how many of those triangles will make up this whole regular 30-sided polygon? 30. So it's going to be 30 times the area of this particular triangle. Okay. So that's our focus. If we can find the area of that triangle, multiply it by 30, we got the area of this whole polygon. Well, we need a little more information to come about this. So what is something else we can find about this triangle? It's isosceles, okay. Find what? Its length. We want to find its length. We hope we're headed that way. Not an easy process, so. What is easy to come up with, though? Is there an angle we can find? How about this angle right here? What's that going to be? 60. Why is it 60? Okay, all the triangles will be congruent. How many then there's 30 triangles, right? So there's 30 of these central angles. I'm not going to fit all in there, and they're all congruent to each other. Would they all be able to be 60 if I have 30 of them? Is 30 times 60 360? That's way too much, huh? 30 times 6 is going to be 1,800, I think. Way too much. How are we getting 12? So 360 is your full circle, and that 360 is shared between 30 of these central angles, and so we divide this by 30, and we get 12 degrees. So that central angle there is going to be 12 degrees. Okay, so that's going to be important for us to know there. So we have the 12 degrees, and then we got to work from there. We're after the height of that triangle and the base of the triangle, because that's how we find our area. Our area is 1/2 base times height. You guys have the math background, so that's why I'm pausing and trying to get you thinking ahead of me if you can. Anybody know what we can do to find the base or the height of this particular triangle? It's not a special right triangle. We're going to have to use our calculator. Anything we've done in the past that might apply? Yes. So right before Christmas break, we learned about sine and cosine and tangent. We're going to have to use that. Okay, that applies when we work with right triangles. But if I draw my altitude, I create a right triangle. It splits my isosceles triangle in half. I'm going to just enlarge that and put it right here. Okay, we'll zoom in on it. Here's 4. What will this angle at top be? 6. Cut that 12 in half. And we're after, let's call the height of the triangle, and we'll also call this side x. We want to know both of those because they're both going to help us find the area of this isosceles triangle. What we did before is we drew a similar triangle, meaning all the angles are the same, but it's not 60, 6 degrees. But it's just scaled down to a hypotenuse of 1. So this is still 6 degrees here, hypotenuse is 1. And what we said, when you have a right triangle with a hypotenuse of 1, the side across from the angle is the sine of that angle, and then the adjacent side is the cosine of that angle. And then these are similar, so you can set up proportions. For example, if I want h, I could say h over 4 is equal to cosine over 1. And then solving for h, multiply both sides by 4. Reduce this fraction, you get h is 4 times the cosine of 6 degrees. So we found our height. We've got 30, 1/2. We're still looking for the base, but the height is 4 times cosine of 6 degrees. The base is right here, but x is going to be half our base. So if we find x, we can double that to find the base of our isosceles triangle. Right, so this base right here will be 2 times x. And I can still use these two triangles to solve for x. We can say x over 4 is sine over 1. And multiply both sides by 4. And you get x is equal to 4 times the sine of 6 degrees. So what do I put in for the base? 8 sine of 6. Because remember, the base is double x, right? 2 times x. And so if you double that, you're going to get 8 times the sine of 6. So now we have everything we need. You could, at that point, put in your calculator, or you can simplify this a little bit. You could use, if you want to simplify, you could say, well, 30 times 1/2 is 15, and 8 times 4 is 32. And you still have the sine of 6 degrees times the cosine of 6 degrees. But eventually, so if you didn't have a calculator, this is where you would stop, right? You can multiply the 15 and 32, but you can't go any further. But if you have a calculator, make sure it's in degree mode and try it out. And rounding to the nearest hundredth, we're going to get approximately 49.90. And we were looking at feet, so this would be square feet. So if you do have a calculator, try that out. Make sure you're using your calculator correctly. Make sure it's in the right mode that you can get that. If you have any issues with that, let me know. I could help you out with that. Okay. All right, so I'm going to give you one more of these examples. And this next time I'm going to have you try it, give you a little more time, see if you can follow what we did in number one, and apply it to this new one. Example 2. Find the area of a 24-sided regular polygon. This time I'm going to give you the apothem. And let's say that that's equal to 4 inches. All right. So give that one a try. All right, so I'm going to start working through this now. We got 24 regular sided polygon. So the area of that is going to be 24 times the area of some triangle, right? And so if I start to sketch this polygon, it's going to have a bunch of sides. And they tell us from the center to a midpoint, that's your apothem, not a vertex, but a midpoint, and it's perpendicular, is going to be 4 inches. Okay, and so here's the triangle we're working with a height of 4. So we already know the height of that triangle. That's nice. We just need to find the base. So we got 24 times 1/2 times the base times the height of 4. So it's 24 sides, so I'm going to divide 360 by 24 to find that central angle there. And what do we get? 15. Okay, so 15 degrees. And even more so, we're going to just focus in on the right triangle. I'll let this side be x, this side will also be x, right? And so we're going to add those together at the end. So if I split 15 in half, now we're looking at 7.5, right? So 7.5 degrees. And then you got another 7.5 on the other side. So I'm going to draw a similar right triangle, scaled down a little bit. So still has the 7.5 degrees. Hypotenuse of 1, this would be the cosine of 7.5. This would be the sine of 7.5 degrees. And 4 and x correspond to cosine and sine. And when we use both sine and cosine, remember we're going to change it to tangent. And tangent is sine over cosine, so I need to put it in that order. So x over 4 is the sine of 7.5 degrees over the cosine of 7.5 degrees, which is the same thing as the tangent of 7.5 degrees. So I can kind of ignore the middle now. I'm going to multiply both sides by 4. And I get x is equal to 4 times the tangent of 7.5 degrees. So that's x. I want the full base, so which is x plus x. So if I add that with itself, what do I get? 8 tangent, and you just keep the angle 7.5. Don't change the angle, right? And then from there, you go ahead and find out what you're looking for. So this would be 12 times 32 times the tangent. That's 7.5 degrees. So 50.55. And did I give you units? I said inches, so this would be square inches. Okay. So there you have it.